For our second video, we're going to be taking a look at conditional probability. So conditional probability is the probability of an event occurring given another event has already occurred. The way that we write this out is the probability of event B happening given that A has already happened. So you can actually think of that line as just the word given. So this is kind of hard to explain without doing a concrete example. So for today, actually, we're just going to jump right in and take a look at an example first. The way that we'll frequently see these drawn out for us is in these things called the frequency tables. They will be measuring some quality or statistic. So this table here that I'm copying down is based off your gender identity. What type of pet are you most likely to have? And this was based off a survey of 100 people. So this data is just given to us. And there's going to be a few questions based off of this table. And it'll kind of give us a good way to explain conditional probability. So an example question might be, what is the probability that you have a dog given you identify as male? So in this case, sometimes it helps to write these out. We actually just look at people that identify as male. So given that you identify as male, what is the probability that you have a dog? Well, 42 people that identify as male have a dog, and there are a total of 52 people that identify as male that were surveyed. So it's actually not the total of all of the people that were surveyed here. It's just the total of the people that identify as male. So you can think about these as part over whole type questions. So we'll do like maybe 2 or 3 more of these because these are definitely kind of confusing to do at first. And we'll kind of go through these one at a time. So let's do another one. The probability that you identify as female given you own a cat. So first, let's zero in on what is our part. And then second, what is the whole? So we'll start off, we'll identify the whole in green. So the whole is cats. And then the part that we're looking for is, given that you are in this cat subset, how many identify as female? Okay, so whole here is 49, and then the part is 39. And we'll keep going with this. We can do a few more examples here. Probability of identifying as male this time, given you are a cat owner. So we'll do our whole, cat owners. We'll do our part, people that identify as male. And in this case, we'll see a very different probability. Still both of the numbers together over just the males, or people that identify as male. All right, so hopefully those examples help. I would recommend highlighting or just circling, similar to what I did in the video here, your whole category. That way you're not adding things that you don't want to add in there. So frequency tables can definitely be a little bit tricky to break down, but if you follow these steps, you'll be in good shape. Last thing to go over here is, what if it's not a conditional probability? What if it's just something like just the probability that you have a dog without any conditions here? Like just probability of dog. Well, in this case, there is no whole the whole is everybody. So if there is no condition, we just use the entire table. So here we'd have to add up everything all together. So that would actually be over 100 now. And then all of our dogs are here. So that would be 51. So if there is no condition, it's just out of everything. All right, so now that we have this down, kind of the concept of conditional probability, we can actually take a look at this in a more mathematical context. I do have a formula for this. So we can go through some examples. So this is honestly just a definition to memorize. And a good thing to track here is your whole. The probability of the whole goes on the bottom. So looking at an example here, we can take a look kind of how to go through these, how to do these, which is definitely a little bit tricky. So we can take a written example. 19.1% of the US lives in the Northeast. .4% of the US earns more than $75,000. And are in the Northeast. And we want to find the probability that someone earns more than $75,000 given they live in the Northeast. So that would be the format. And this is the data that we're given. So it's our job to set this up. So probability 75K given Northeast equals the probability of both of these happening. So 75K and you live in the Northeast over just the probability that you live in the Northeast. So in this case, on top, probability of both is here. They give that to us, that 4.4%. And then on the bottom, the probability of just the Northeast, they give it to us as 19.1%. So we can solve for that final answer actually here by just dividing those two quantities out. So we have 4.4 divided by 19.1. That'll give us about 23%. So the probability that you make $75,000 or more and or given you live in the Northeast is 23%. So we're kind of like putting those two things together. And a lot of these are going to be defined for you. So they'll, like, similar to this question, they'll give you the individual probabilities. And then you'll just be plugging them into the formula. All right, so another more mathematical example. So you're not really looking at a table here, kind of just plugging in values into a formula like we've done many, many times this year. And the last thing is we can actually take this probability that we just calculated, this rule here, and there's a second way that we can write it, and this helps us in complex events if we're trying to find things. So if we're trying to find the probability of A and B, we can also write that as the probability of A times the probability of B given A. And this will tell us a general multiplication rule for when we have dependent events. So the outcome of another one depends on the other. That means basically that the probability of B is changed because of A already happened. So two different ways that we found this today. The first video had a different formula for A and B, but now if we have dependent events, basically one depends on the other. The probability of owning a dog depends on your gender identity, as we saw in the example above. We have a new formula now. So these are the two different formulas. Definitely have these copied down and basically be ready to plug them in. That's kind of the idea here for going through and calculating. So with the video and questions here, we're going to have a bunch of examples of kind of plugging these in to get used to them. If you have questions as you're working through, definitely shout them out. I know the first few times going through